Driving a rover on Mars requires humans on Earth to plan the route. Self driving cars on Earth can take advantage of GPS to navigate, but Mars has no global positioning system, so rover drivers have to set waypoints manually. NASA and the company Anthropic just announced that its artificial intelligence model named Claude was used to plan the route followed by Perseverance on recent back to back drives, essentially telling it how to safely navigate on an uncharted world. For every rover mission before, that task has gone to rover planners. RPs are the engineers at the Jet Propulsion Lab who send commands to vehicles so far away that the minutes long radio delay means no joystick operations. For drives just a few tens of meters, they can use images captured by the rover to identify safe routes. But for longer drives, RPs use images from satellites in orbit around Mars. Since 2006, the Mars Reconnaissance Orbiter, with its high resolution imaging science experiment, better known as HiRISE, has been the go to source of images for rover route planning. With a resolution of up to 30 centimeters per pixel, it can resolve rocks a meter across, and the features it can resolve in the location where Claude was tasked with route planning are beautifully shown in comparison with images from Perseverance for scale. The light toned fractured slabs of dust covered rock are nicely contrasted with the darker basaltic sand that fills the fractures. It's easy to identify the exact same features in both the orbital and ground views. This is especially important for potential hazards like large sand ripples that can trap a rover, something that happened to the Opportunity rover back in 2005. This location is at the end of the first of the two drives planned with Claude, which covered about 200 meters, starting with some sharp turns needed to avoid sand ripples. The second drive also required navigation around sand ripples and avoiding rugged terrain to the west. Claude was trained on years of data and information from previous rover drives provided by JPL engineers. This allowed it to learn not only how to recognize terrain features, but also how to write rover commands in the programming language used by Perseverance. The RPs estimate that the use of Claude could cut route planning time in half. Claude laid out the waypoints and rover path shown in magenta, with the green boxes indicating keep in zones. At each waypoint, Perseverance takes up a new set of instructions. All of this was verified in advance by processing the commands on a so called digital twin rover at JPL. The orange lines show the reconstruction of the actual drive after it happened on Mars. This video was created from 53 image pairs taken by the nav cams on Perseverance during the actual drive, as well as other telemetry it measured along the way. All of this was fed into a 3D virtual environment that created virtual image frames about every 10 centimeters to produce the look of a continuous video. In reality, the drive from start to finish, covering 246 meters, took more than 2.5 hours. That's an average speed of about 1.5 meters per minute. So, yes, you could crawl faster than Perseverance, but the tortoise like pace helps Perseverance avoid a bad day on Mars. At this point, route planning on Mars using artificial intelligence is poised to streamline the painstaking work of Earthbound RPs, which could increase the cadence of driving and open up more distant exploration targets for natural intelligence.